Hello, this is the, um, yeah, all right, so this is the class number 2 for physics, and so it's go through the screen sharing here. I'll go as quickly as I can and to get all the material out there. All right, so first off, a couple of announcements. We did add the class wrap-up, and that's what this is. So I will put this link on, the link to this YouTube on here. I write, how about we get a little pointer here, right here. All right, there'll be a link, and there that is. So right here. And then they also added this PDF. So these are PDFs of Packet 1 sheets, and so there's 8 of them here, 8 PDFs. If you came by, it looks like most of you came by and got a paper copy of it. I have those paper copies in my room. I have some at home, so I can help you out there if you want to just get a paper copy. But if you want to go ahead and just print them off on PDFs, you can do it that way as well. We still haven't got to this yet, so you're okay if you haven't got them, but you need to get these by Monday. And this has already changed. I'm going to move these down to here into week 2. So I'll get that fixed today or tonight. I'm doing some stuff with it. It'll certainly be fixed by Friday afternoon. All these due dates and things will be changed and updated. And until we get kind of everything situated, whether we're doing AABB or whether we're doing virtual or whether we're doing traditional, this is going to be a little bit of a kind of a day-to-day thing. But the one thing that won't change, the content won't change. It's just that the due dates will change. But I will put that in announcements, and I'll give you a warning of when these things are due. The assignments are here. You have these, if you in your tab on the left side, you should have an assignment. And notice that, let me blow this up. This, okay, see this date here, this, and this. I think that's probably right now. This is from first hour. But if you're in second hour or third hour, you may not have noticed that. So I will fix it. I will fix it in all the hours. I'm going to put all of you together, this cross-link or cross list, all of you together, all classes together except the virtual. The virtual will be linked together as well, but still I'll have 2 sections. I'll have all the in-school kids and all the virtual kids, because I'm going to treat you as close to as I can to the same. You get the same material, but there's just no way I can have the same experience virtually as I can have in class, because physics is all about activities and doing things, and the virtual students will be able to watch a video of something being done, or I'll give them some instructions to go do it on their own, but they just won't have that classroom activity. I don't see how to replicate that. Anyway, so they will be covering the same material. All right. Now, so these are all, this is all, the dates are wrong on these, okay? The dates need to be, will be fixed. All right, keep going. And the quizzes, now this is, we covered enough material on Thursday, and we will again on Friday, that this is already done, but I'm going to change this. I decided this morning to change this. It says it's available until October 26th, but I'm going to change that to, like, I don't know, I'll give you another week, because people are coming in late, and so it's not fair to them to not let them even take it. So it was due the 26th, but I tell you the truth, I'm probably just going to change that too, to allow you to do it up through, I guess, the end of next week. I mean, what do I care, right? It's just a dumb little 3-question about first day. Now this is due Sunday night, okay? It's available. I may make it available a little longer, but it's not available until the 28th. And the reason for that is, I know I'm filming this on the 27th, but second hour has not had a class yet. So I won't release this video or this quiz until the 28th. It looks like at noon. So at noon, everything gets released. That is due on Sunday night. Okay? I know it's odd, and hopefully we only do this for a couple of weeks, but there's a good chance we'll end up being virtual, in a month or in a few weeks from now, and then we're virtual for a while, or the flu season comes and we're virtual all the way to Christmas. So who knows? It's a rodeo. So we finished last time with this question, can you really sit still? And we're beginning to see the answers no, but now we need to quantify that a little bit, like how fast, and remember, everything is a dot for now. For the first semester anyway, probably all the way till February, everything will be a dot. A rabbit is a dot, a horse is a dot, you're a dot. Your car's a dot. I mean, even the world, the Earth, if we're looking at an Earth-Sun system, the Earth is a dot. Our whole solar system might be a dot. So and that dot being at the center of mass. So I really am a dot, and I know I'm really tiny here. My picture's really tiny, but my dot's like right here. That's my center of mass. So, so the question is, can your dot be still? I mean, you can move all your arms and your dot still isn't moving. So relative to the room, but the discussion was on Monday, Tuesday that, well, if it's relative to the axis of rotation of the Earth, you are moving. And in Oklahoma, you're moving. We did this calculation. In physics last year, but in Oklahoma, you're moving at 850 miles an hour. The circumference of the Earth is moving, the equator of the Earth is moving at 1,000 miles an hour. Well, there's a curvature, right? So if you go back to where Oklahoma's latitude is, we're moving at 850 miles an hour. The question is, how fast are you moving if you're standing at the North Pole? Well, you're just going around and around in circles. You're not moving, you're rotating. So at the North Pole, if you could put something above you, a helicopter that wasn't rotating with you, would look down on you and see you going in a circle. Or if you're right at the North Pole, then it would just be a dot that would stay there. But the faster you go, standing on the surface of Earth would be 1,000 miles an hour. So if you think about it, there's 24 hours in a day. Therefore, the circumference of the Earth is 24,000 miles. That's an easy thing to remember. It's to two digits, two significant figures, which we'll get to later, to an approximation. Let's just say the circumference of the Earth is about 24,000 miles at the equator. The Earth is called an oblate spheroid. It's not perfectly round. It bulges in the middle, partly because of inertia, but it gets thrown out. And I have a machine that, when we get to class, I can show you. It's pretty cool. Shows you that bulge. All right. So now the main question we tried to answer in our time on Thursday, Friday is, how fast is the Earth going around the sun? Now you'll have a quiz an exit quiz that you can take starting tomorrow up through Sunday night. And one of the question there's 3 questions that are multiple choice. They're not that hard. You can look them up pretty easily, either on Wikipedia, or you can look them up on, you watch the Zoom from Monday, Tuesday. But the 4th question has to do with this. And so that's why I think it's important that you write this out, that you try this on your own. Just hit pause, okay? A lot. All right. So what we're answering here in class is, how fast is the Earth going around the sun? But on that quiz, the question is, how fast is the moon going around the Earth? And my point is, you'll solve it the same way as you would the Earth going around the sun. You ought to, on those exit quizzes, try them on your own. I have no problem with you asking questions about it, with you asking me or asking classmates. You can go on the Facebook group. That's a really good place to go. to ask questions. Remember, the Facebook group, I'm going to go ahead and write it down again. The name of the Facebook group is Askey Physics. It's all one word. No, wait, it isn't. It's Askey space. I'm thinking of something else. It's Askey space physics fall 2020. Okay, join that group. You'll find a ton of Askey physics groups. So be careful which one you join. If you try and join spring 2020, nothing will happen. You won't get in there. So you got to join fall 2020. Okay, keep going. So this is the question we're going to answer, and if it doesn't make sense, you can ask questions about it on the Facebook group or in Canvas. But Facebook group, from what I can tell, is a little more user-friendly and back and forth discussions, and just a better job of keeping track of our discussions, and very visual. You can put pictures, you can put videos, all kinds of cool stuff. And we don't have problems with space. The Canvas only gives me 524 megabytes, which is nothing. So I have to be really careful what I put on there. So everything has to be links. Okay, so in the Facebook group, we can add all the movies and all the stuff we want and not have to worry about, running out of space. So, all right, so we'll start here. From Algebra 1, you have this you learn this little formula, distance equals rate times time. But that is a very bad, this is bad. It's bad for physics because, for one thing, we don't use those symbols, and there's reasons. We don't use this. This is called little d. We don't use, we use this is little d. We use little d for derivatives. So it gets mixed up. And so nobody, except for Algebra 1, uses little d for distance. In fact, distance itself is like a 10-cent word. It's not a very good word. Displacement is the $10 word. So distance, we'll get to the difference later, but little d is just not good. Let's leave it at that. All right, so instead of saying little d, we say, let me move this up a little bit. I'll do that. Okay, instead of saying little d, we say delta s. And this is it's pronounced delta s. Now delta, this is delta, and delta means change. And by the way, if you see this stuff over here, just ignore it. Those are notes from last year. Like, we would keep track of everything we did in class, and so I'd write this big long thing out. So I'm using that to kind of keep me honest, to make sure I cover at least most of what we covered, try and cover what we covered last year. It's going to be hard to do only meeting twice a week for 50 minutes as opposed to 5 times a week. See what I'm saying? We're going to have trouble. There's just no way I can spit out enough. And you can't, for one thing, you can't rush physics. You just can't. Students will rebel so within a week, and you'll have a massive revolt on your hands. So I'm going to have to find a way to still get information to you without just lecturing all hour and without just, talking as fast as I can. It's not going to work. I've tried that before. It doesn't work. So we're going to have to pick and choose what we talk about, which is crazy because, like in math, say, well, we'll go ahead and talk about addition, but we're not going to talk about subtraction. We'll just skip subtraction this year and just talk about addition. We'll talk about multiplication, but not division. You can't do it. It's the same thing with physics. Physics is based on math, and you can't just talk about bits and pieces. So I'm debating in my head whether to go through and hit a survey and hit all the highlights, and then having half the time just going right over your head, and you're hearing it, but you're not getting it, or go at the same pace I normally go, just don't cover as much. Either way has its disadvantages. So, sorry, I'll cut that out. Me complaining. And this S, this is, I mean, it's nobody's fault. I'm not blaming anybody. This S is the symbol we use. This stands for general position. So you're used to, in math class, for position using, okay, so this is general position. This is a combo. It's a combo of X, Y, Z, all right, the 3 dimensions. So sometimes we'll just stay in X, or we'll stay in Y, or we'll stay in Z. In fact, most of the time, we'll do these. That's one-dimensional physics. But what we're about to do is 2-dimensional. And I know it sounds weird, but it's not as bad as it sounds. So sometimes we use X, sometimes we use Y, sometimes we use Z, and sometimes we just use S if it's a combination. See what I'm saying? So we say delta S. All right, got through that one. So no longer do we don't ever say D. And then for the next one, this is R, which they say R for rate, right? The rate. Well, you can't use the word rate in physics because it's too general. Rate means slope. Rate means something changing over time. Well, rate could be velocity. It could be acceleration. It could be something called jerk. It could be something called snap, crackle, or pop. All of those are in kinematics are examples of rate. There's other kinds of rates as well. How fast is your mass changing? You know, we call that m dot. So those are all examples of rate. So R, for one thing, we use the lowercase r for radius, and so we can't use that. But R is what we use there. In this case, for what we're going to do, we're going to call that V, right, for velocity. So that is velocity, which we just give the symbol V. Lowercase v. Uppercase V is voltage. So physics is its own language. Yeah. And then finally, T, yay, we get to use T. T is just time, and that lowercase t is what we want. So that was okay. So putting all this together, and this is the way physics is, though. Physics can be, it's a little off-putting at first that here I am trying to talk about one simple thing, and I want to do that as much as we go on, because you can go back and watch the tape, or we'll start to finally get these. I'm getting all these definitions to you right now, and then we'll have enough information where we can build on it slowly. I'm not giving you so much so fast. All right, so the equation that we use, instead of saying D is equal to RT, we will say delta S equals V times T. And there, my friends, is our first physics equation. And we'll use this equation next week. We'll use it off and on. We use it throughout the year off and on. We'll develop a set of equations. Now, question you might be asking right now is, should I be taking notes? Well, you'll have this YouTube video forever and ever. I don't plan on taking it off YouTube. So, but the thing is, you don't want to keep going back and watching videos. So probably just time consuming wise, who wants to watch this again? So you probably ought to just write some of this down and just keep a log by day to day as to things. We keep a notebook, but it's a really nice notebook, and the district just can't afford it. They don't have any money, not much money this year. So they would love to. The district has gone crazy helping physics with notebooks. The notebooks we use, and I should hold up an example in class. I don't have one here. I'm at home right now. But the notebooks we use are they're literally almost $20 each. But we get them in bulk and we pay less, but they last forever. And so the district has committed to helping us, but unfortunately they just don't have the money this year. So this is our, so I guess what you should probably do is just write it down on paper for now, and then we'll decide how we're going to do notebooks once we all get back together. Um, and then you could like take pictures and keep a like a virtual folder, probably. Maybe that's good. Like once you fill up a page, take a picture of it and then just store that. Anyway, we'll discuss it. This is our first, oops. This is our first physics equation. Yay. Woohoo! All right. So now we're going to use this equation to solve, and that's what I wrote. This was from third hour. So you see it's the same. I'm trying to make this even more thorough because this is for the record, right? That was like off the cuff. I mean, as we're talking. It's one reason why, that's one reason why I have had such a hard time with assignments, even for just a week ahead, because a lot of what happens depends on the questions you ask. The questions, and tell you the truth, first hour kind of runs the show because it's the first class I have. And so what happens in first hour has to sort of take place just to keep all the hours in the same place. But I want to be free in first hour to go where the discussion goes, so I keep the course is a bit amorphous there. It's always been that way, and that's one of the beauties of it. It's one of the interesting things about it is that every time it's a little different. So me putting together assignments, I'll do it, and we will get to them, but things might get moved around all the time. So I will always give you my best guess, especially for virtual kids, but virtual kids can rely on these videos to keep them going. And virtual kids, by the way, can join in on any live Zoom. They can be there, and I keep saying Zoom, but the district now is pushing towards Google Meet, so next week it may be Google Meet. What are you going to do? Yeah, so they have the reasons, but let's keep going. So this is, I wanted to point this out. This is from last year. We had the same discussion, and I put this on the board. And then I posted, last year I would post all the screenshots from that day, that in order, the best of the screenshots onto Facebook, our Facebook group. And then we would put captions. I'd put captions on each one of those. And so it was really cool. Well, I was going to do that with Canvas until I found out that I'm so limited on space. You start putting all these images on Canvas and all these captions, you're going to run out of space in a couple of weeks. So instead I'm doing these Zooms, doing this YouTube stuff, and that will make it as a link, and it's me trying to recreate class. So we'll see. I don't know. We do have a Facebook, so maybe we'll put, but then it's already enough. It's already so much work. I may just have to have the virtual kids. We'll see. I'll shut up because I don't know what's going to happen yet. Well, we're about to work a problem that's similar to the problem in your homework in the quiz, and we're about to work a problem, but the equation is delta S equals V times T. But we're in this particular problem, we're going to solve for velocity. So you divide both sides by t, the old algebra 1. You divide both sides by t, and you get v is equal to delta s over t. You actually get delta s equals v over t, but the standard is to, in any kind of textbook, is to put the isolated variable on the left. So I isolated my velocity, so it's on the left side. Equals delta s times t. So we're going to, this has a lot on there. I'm sorry, I jumped ahead. I should have kind of gone back and worked this, but I'll go and explain this one. So the question is, how fast, the problem we have to solve in class is, how fast is the Earth going around the sun? So we're going to use this equation, delta S equals V times T. Now, we talked about this in class, and we said, well, what is the, if the Earth is going around and it's, okay, I'll do this. It's going around in a circular It's going around a circular path. Now, it's not really going around a circular path. Kepler, when we talked about Johannes Kepler last class, and when he looked at paths, he realized that, that they were not circular. They were elliptical, and with the sun at one of the focus points. Remember ellipses have a focus point, and the sun. In fact, the word focus means heat. It means fireplace. So that sun is the fireplace, right, for the solar system. So all orbits are really elliptical, but we're going to say, for simplification for now, and that's what happens in physics. You start off simple. So there's the sun, there's the earth going round and around. So you start off simple and you learn some of the basic equations and the basic relationships. And then the further you go, you can go up to a PhD and then teach it and then study it the rest of your life. And what you end up doing is you're going back and you're filling in more and more and more details, right? Or you're getting really small and you get into quantum, or you're getting really fast and you're getting into relativity, So we just study classical physics. So a lot of times you'll see me simplify a situation for us to get kind of in the ballpark, and then later we'll go out and fill out details, all right? So Kepler showed, just from the data, from Tycho's data, that orbits are elliptical, and that he didn't understand why. He thought, well, this is trying to understand the mind of God. I mean, he did this harmonic sphere kind of thing, and trying to show the glory of God, right? Physics and religion are run parallel. They break off, and sometimes physics and religion do this, kind of like it's doing now, and sometimes they join up, and sometimes they do this. This is what they're doing now, right? More like climate change, whatever. I mean, politics, religion, physics sometimes don't mix. But historically, physics and religion have a lot in common. So we don't talk religion in class, but it comes up. It has to, from a historical point of view. I mean, look at Bruno. I mean, if you want to look something horrible, look at what happened to Bruno, 1600. Anyway, so Kepler talked about this harmony of the spheres and God, but he didn't understand why anything was happening. He quantified astronomy, or at least in our solar system. But Newton, about 100 years later, showed why. He showed why it's ellipses. So, but we're going to say that this is approximately circular, so that we can use simplified formulas. So this is, of course, the formula for circumference. And 2 pi r, you could say pi times d, but pi times d it's the same formula, but 2 pi r is more preferred because of what's going to happen later in calculus. So we say 2 pi r, not pi d. I'm sorry. In this case, d means diameter, right? But 2 pi r being radius. So I will give you, we're trying to figure out how fast the Earth is going around the sun, and I'll give you some information. Last year, I gave it to them in light minutes, and then they had to do a bunch of conversions, but we're not in class together. I mean, that's okay to give you something like that if we're all in the same class, you're at the board, and then I can kind of help you work your way through it. But here, it's just too much. It's too much to ask of you through a Zoom to try and get there. So I'm going to say 92 million miles. That gets us close to the answer. So we're trying to find out, hold on a minute. Okay, we're trying to find out then, how fast is the Earth going around the sun in miles per hour? Okay, so let's go through this. You should probably push pause, and then, knowing that formula, try and solve it yourself. Just watching me solve something is a waste of your time, and you didn't learn much of anything. Remember day one, you have to fail. You have to try it and get it wrong, or try it and then just go as far as you can and go, okay, I need a little help. But don't just sit and watch. That is, okay, so V then equals delta S over T. And the delta S we said was 92. We said sorry, that's wrong. The delta S is 2 pi r, so it's 2 pi times 92 million miles. And we divide that by the time it takes to go one complete revolution. Now, in that case, the symbol we use is little t, means time in general. I'm going to write this down. We didn't talk about this in class. This is a wrap-up Zoom bonus. We'll get to it later, but if I'm going to actually talk about a particular time, especially if it's harmonic, goes round and around and around, we call it capital T, and that stands for period. But I'll go ahead and leave it as little t here. So this is a year, right? A year. Well, that's great. We got, if this were a problem and I was giving you a test and you left that as your answer, you'd get probably 6 out of 10 points, maybe, yeah, because there's still quite a bit of work to do. We got to get it into, I want the answer in miles per hour. So how fast is the Earth moving in miles per hour? Okay, not miles per year. So now I got to do a little. This is something that you learned if you took chemistry. If you didn't take chemistry, that's okay. I'm going to teach it. I'll teach it to you. And I'm giving you a little. This is like a little preview. This is the way we want you to do it. At this point in the year, if you just do some chicken scratches and start figuring out, let's see, it's 365 days in a year, blah blah. That's okay for now. But I'm going to show you how. Eventually, we want you to show it. Okay, so to do this, we have our formula here. I'll keep it in symbols above first. We have 2 pi, that's my coefficient. I have delta S is going to go here, and then not delta S. Delta S is 2 pi r, so I'll put my r, let me erase that. I'll put my r here. And then I'll put in this slot, I'm going to put my 1 over t, because it's really 1 over t, right? Notice that it's not t up here, and let me put my pointer here. It's not t up here in the formula, it's 1 over t. It's the inverse of t. So that's why I made that 1 over t down there. All right, so I do this, I'm kind of following, this is called gold standard method of solving in analysis. And I'm trying to do some early training. We don't get to gold standard until the 5th paper. So it'll be a couple of weeks before I'm just giving you a little preview. All right, don't freak out on me. All right, so this is 2 pi. And I had a student, I think, ask a question and said, wait, is this like what we're supposed to be doing? I mean, are we supposed to know all this? No. You go, well, I couldn't do this on a test. Well, of course not. It's day 2, man. I mean, with the test, the midterm is not till first part of October, last part of September. So we got plenty of time. And you're going to get a take-home test. You're going to get practice problems. You'll see, which we'll all work together, and you'll get to work them, and you'll get to work them with friends, and we'll have parties and all that. I mean, I don't know about COVID, but all right. So don't freak on me here. I'm just showing you a method, and this is the first time you've seen it. So this is 92. I'll go ahead and write it as scientific notation. 92 times 10 to the 6th. Excuse me, miles over 1. And that's another Zoom bonus, wrap-up bonus, because I did it just as, I went and wrote out 92 million. I was gauging the crowd, and I felt like they were starting to get angry. So I didn't want to throw that at them, but you're not here now, so I can. Yeah. Then 1 over t is 1 over a year. Well, the problem is I want my answer in, let's go back over here. I want my answer over here when I'm finally done. I want the answer to be in terms of miles per hour. So I've got to get that year and fix it. All right. I got to get the year in terms of hours. All right. Well, we'll work our way towards it. A year has, let's do the stuff we know. Well, we know that a year has 365, and we'll go ahead and throw in leap years. So 365.25 days in a year. Now notice I put year on top here, days on the bottom. These are all clever forms of 1. This is just 1. I can multiply anything I want by 1. So these are all conversions. Sometimes I'll say con. In fact, I'll say that. All conversions are just clever forms of 1. So pause that, let that sink in. This is a con. Okay? Con is in conversion. And then let's go days, let's go hours in a day. And so we say, okay, in a day, now let's round it. It's actually, if you go, it's not really 24, but we'll go ahead and say 24 to two digits. Okay, 24 hours. Okay. Now notice that when I multiply this out, I'm going to use a green pen. The green pen will be my kill pen. I can kill off things. I want to keep, I either circle or kill. So I circle the miles, because that's miles is in my answer, see? So I want to circle it. I want to protect it. Years are not my answer, so I got to kill them. So I kill year and year, and that's the green slash. Okay, you can say slash. Days is not my answer, so I slash the days. Hours is, so I circle it. So I'm following this gold standard method. And once you learn the gold standard method, it takes you a couple of worksheets, but about, you're not going to like it at first, but about March, late February, my kids last year started coming around and really wanting these kind of questions on tests because they got so good at it. And this is a training I'm doing. It's a skill that once you learn it, you can solve so many problems in chemistry and physics, in any kind of engineering. You're always doing this. You're always doing problems this way. Okay. So you punch it all in, and now when you punch these into your calculator, students were having trouble here this morning doing this, because when you're punching, you just can't just punch numbers into calculators without using parentheses. Well, and by the way, as far as a calculator goes for this class, you probably just, Walmart $10 special is okay, but it should have sine, cosine, should have x squared button, square root button, those kind of things. They're about $10, $11. Actually, your laptop has one that works just fine, okay? Except on tests, you can't use it, so that's the problem. I have some calculators in my class. We'll get to that later. Okay, so to solve this, sometimes okay, I'm going to push pause, and then I'll go ahead and punch these numbers in and come back to you. Pause. Oh, I see pause share. No, wait. Okay, I don't see I'm still kind of new to this, so I don't see a quick way to pause the Zoom. Stop the video. Okay, I'm afraid I'm going to stop it. I got to start over again. So let's just keep going. You'd multiply all these top numbers together. So I don't have a calculator with me. We'd have 2 pi times 92 times 10 to the 6th on top. I don't need units because I already got my units here. And then on bottom, I would have 365.25 times 24 on bottom. And unless you're good with your parentheses on calculators, I'll probably just go ahead and do this first. Go ahead and do this part first in your calculator, see what you get, and write that number down or store it, and then do this. Unless you're good with parentheses, do this second in your calculator, and then then divide one into the other, just to be safe. Okay. So the answer ends up being around 65.9, but to 2 siggies, we say the answer is 66,000 miles per hour is how fast the Earth. So the Earth is screaming through space at, I mean, think about it. You know, the Oklahoma is moving at 850 miles an hour at 24 hours a day, you know, 7 days a week. But the Earth is moving at 66,000 miles an hour to try. That's how fast it's got to go to get around the sun in 1 year, which is crazy fast. Okay, so we've talked about two relative motions. The last problem on your quiz has to do with the moon going around the Earth. You can wait till tomorrow, till Friday at noon, and then print that off, and then not print it off. Just it'll open up for you, and you can take that quiz right there in Canvas, and then submit it right there in Canvas. Okay. Okay. So I guess I'll sign off. That's about as far as we got in class. It's just not far, and we're not going fast enough, but not much I can do about it. So, so what's next on here? Oh, so that's the end of Packet 1, Class 2. All right. Made it through 2 classes. All right. I will pause. I'll stop this and stop the sharing, and then I'll stop the recording.